Now let us look at the stack implementation using the linked list. Stack using linked list. First let us clearly understand the problem statement. So what does stack means? It basically follows the LIFO principle, that is last in first out principle. And when we are implementing it using the linked list, so we need to understand the properties of linked list. Here we are using the single linked list, and the second thing is it basically dynamic memory location. So the stack, the data elements in the stack can now have a dynamic memory, so that we'll be able to add any number of the elements as per our requirement. So it, unlike while implementing using the arrays where we have only the static elements in the stack. So let us see how it will be looking like. Basically, if we take this as a stack, so here we'll be having one node, and then here we will be having the another node, and then here we will be adding the another node. So we can keep on adding the new node based upon our requirement. So how we can add the new node? We already saw it using the malloc function clearly in the linked list. So basically here you can understand the problem statement in this way. So let's say there are two ways of implementing stack. One is, so we know the stack will be of this way, right? So here will be head, and he will be having the data point, and here we will be having a link or next pointer. So this is correct or this is correct. Let us see so the difference between this thing and this thing. So which is correct to implement the stack, by using which type of linked list it is good to use or implement this stack. So now let us check. So if we have the, so it means the head is here, right? So here the head is here the head is here. So whenever here we are, so in the first case, in the second case, if we take, whenever we are adding the new element here, we should always traverse from the head, means we need to traverse from head onwards until the tail, so that only we can add the new element. So what is the order of it? So what is that complexity of it is order of n. If we are adding at the head itself, so we need not traverse any, so we did not traverse any further. We can directly insert at begin or inserted or deleted begin. So we can use these operations, and we can only insert or delete or perform operations of stack at the beginning of the head of the linked list. So in this case the order, it is the complexity is order of n, because we are not traversing. If we are using the last, so if we are using the tail, means we need to traverse from head to tail again. So then it is, the complexity is order of n. Here the complexity is order of 1 only. So it is better to use the case 1. So it is better to insert at the begin and delete at the begin instead of at the tail, so that there will be less complexity, and there will be quick operations that can take place in the data structures. Okay, so again we will understand. So here also we'll be performing the stack operation. So what are the stack operations we perform here? So we'll be performing the push operation, pop operation, and search operation. We can perform the top operation, we can perform the display operation, and any other perform as per requirement. So these are the standard operations that can be performed on the stack. So first let us understand the push, void push. Before it, let's define the structure of a node, and then we'll continue for it. So firstly let's define the structure of a node. Struct node. So what are the elements present in it? One is the data component and other is the link or next component. So struct node star next. These we have already seen it in the linked list. And I will be taking the head, or here we will call head as a top. Okay, so initially top will be pointing here, means as there are no elements currently available in the stack, so top will be pointing here, so it will be pointing 0. Let's say struct node star top is equal to 0, or you can put it as null, it is fine. Now we will be writing the push. To push an element we need to first scan that element from the user input. So enter element to push into the stack, and percentage d ampersand, let's say it is be x, so we'll be defining the x int x. Okay, and now let us take we need to create a new node, so we'll be using this statement, struct node star new node, struct node star malloc function we will be using, and where we'll be using the size of the data type, right? Size of struct node. So by this a new will be created, a new node will be created. After creating the new node, so we need to enter data into it. So new node, the data will be x, and so we have entered the element here x. So let's say x we took, let's say 10, so here 10 will be there, and here there should be 0 or null. So what we'll be writing is new node of next is equal to 0, and we should increment the top after push. So I will be incrementing top to here, that is I will be, so this is the new node, right? I will be assigning top to new node, so top now will be the new node. So yeah, this is how we can push any element into the stack. We also need to understand here, so here there will be no overflow condition plausible, no overflow condition possible. Why it is not possible? Because we are using the malloc function here. So that is dynamic memory allocation we are using, so we can insert any n number of linked list or nodes, so to implement this stack. Yeah, so this push is fine. Now let's look at the pop. Void pop means pop means will be it is like a delete begin, it is like a delete begin. So in general for popping we'll be checking like if there are no elements in the stack, that is no nodes present in the stack via linked list. So first we need to check that condition. If top is still pointed to 0, that is top is pointed to null, then what we need to printf is no nodes in stack, or no data elements present in stack. So this is the first condition, and the second thing is else if let's say there is only one element, that is else if top of next, top arrow next is equal to 0. If we are having, it means there is only one element. If there is only one element, it means it will be 0, right? The top will be here, right? So this is the case. If this is the situation, then what we need to do is, so we simply need to free this top element, that is we'll be deleting this top element, and we'll be assigning top is equal to 0. Okay, so top is equal to 0 means it will be assigned here, means it will be top is equal to 0, we'll be freeing this thing. So basically what free does is be what free of top will be doing is that simply remove this the active linked list. And in any other case, that is if there are multiple, that is the third case is here there are no nodes, here there is one node, here there are more than or equal more than one node. If there are more than one node, let's see this situation. If there are more than one nodes, let's say we have two nodes, let's say this is how it is. So now this is the head, right? So now this is the top. So we need to delete this element and assign top here. This is what we need to do. So in other case, what we can do is, so let us take a temporary variable like struct node star temp, and I will assign this temp to top. So currently the temp is here, and now I will increment the top. Top is equal to top arrow next. So now top is here, now top is here, not here. And now I will free this temp. So after freeing this temp, so this will be lost and top will be here. So this is the only node that is active in the stack. We can close it. So this is the pop operation. Now let us look at the display operation. Void display. So display, how we'll look at it, we'll see. So if there are no elements present, that is if top is 0, means we need to print that there are no elements in stack. Stack is empty, that is empty stack. We can say simply empty stack. Else in any other situation, so we need to display the elements present here. Let's say we have two elements. In this way, here there will be a top. So this is the head, right? So what I need to do is, I will be writing the while loop, while temp until temp not is equal to 0. I need to print temp arrow data. I will be printing continuously temp arrow data, and I will be incrementing the temp. So where here temp means we'll assign struct node star temp is equal to top. Now temp is equal to temp arrow next. So by this here it is temp, and the temp will be incremented from top to here. So the temp initially will be here, and then the temp will be here, and in the next step temp will be null. So the loop will be stopped. So it will be printing all these elements. Now let us look at the peak function. Void peak. So I need to print the node which is at the top, that is the head node. I should be able to print, right? So here top will be present. So simply, so if top is equal to 0, we need to print stack is empty. Stack is empty. In any other situation, we need to print like this. So top element in stack is %d top. So I need to do like this, right? Top of data, top arrow data. So this is the peak function. Similarly also we can write the search. So for search, what we will be doing is, let's say this be the linked list. So linked list series. So I need to firstly need to scan the element from the user. So which element to be searched? So printf enter the search element, enter search element. So scanf percentage d ampersand, let us name it as x. So I will be defining int x. This is the top, right? Now what I will be doing is I will be traversing from head to end, so that where I can be finding the element which will be getting from the user input. So I will also initialize one temporary pointer, struct to node star temp. So where I will be assigning temp to top. Okay, here temp will be also here. No, so temp is equal to top. Okay, now it is fine. So here also we need to do something. If this is the standard, right? If the top is 0, we need to print that stack is empty. So else in else situation, so we need to print and scan. So now what we can do is, so we'll be running the while loop. So while temp not is equal to 0, until and unless temp not is equal to 0, we'll be checking the condition. If temp arrow data is equal to x, if it is so, we need to print data found. So we can print data found, and we can break from this loop also. Before it we can do something. So let us also take something like flag. Initially we will be initializing it to 0. So if it the data is found, element is found, then what we can do is flag is equal to 1 we will be initializing, then we will be breaking from the loop. Means it will be breaking from this loop. Now I will put the condition. If flag is 0, then we can say printf element not found, element not found in the stack. Desired element or search element is not found in stack. This we can print. So this is the search. So here also we need to understand the complexities. So here in search we have used the one loop, so it will be order of n, and in the peak we haven't used any loop, so it is order of 1. The complexity is order of 1, and in the display also we have used one loop, so it is order of n. Here in pop also we haven't used any recurring thing, so it is order of 1. Similarly in push also it is order of 1. So in push, pop and peak, so in push function, in pop function, in peak function, in these three it is order of 1. And in the search and display it is order of n. So it is push, pop, peak, in these three order of 1, and in rest of the cases it is order of n. The complexity is order of n.